Charles' law states that holds V1 over T1 equals to V2 over T2, but V1 is equals to 500 cm cube, T1 is equals to, in bracket, 27 plus 273, which is at 300 Kelvin. T3 is 127 plus 273, which is 400 Kelvin. On substituting these values, we get 500 over 300, which is V2 over 400. Therefore, V2 is equals to 500 times 400 all over 300, which is 666.6 cm cube. Pressure law. Pressure law states that the pressure of a fixed mass of a gas at constant volume is proportional to absolute temperature. P is inversely proportional to T, or P over T is equals to a constant. Therefore, P1 over T1 is equals to P2 over T2. Example 6. A column of air 10.0 cm long is trapped in a tube at 27 degrees centigrade. What is the length of the column at 100 degrees centigrade? Solution. Assuming that the volume is proportional to the length by Charles' law, P1 over T1 is equals to P2 over T2, but V1 is equals to 10 cm, T1 is equals to 27 plus 273, which is equals to 300 Kelvin. T2 is equals to 100 plus 273, which is equals to 373. V2 is unknown. On substituting the value, we get 10 over 300 is equals to V2 over 373. V2 is equals to 10 times 373 over 300, which is equals to 12.4 cm. The length of the column at 100 degrees centigrade is equals to 12.4 cm. Example 7. A gas at pressure 0 Newton per meter squared and temperature 27 degrees centigrade is heated to 77 degrees centigrade at constant volume. What is the new pressure? Solution. Since volume is constant, pressure law holds. P1 over T1 is equal to P2 over T2, but P1 is equal to P Newton per meter squared. T1 is equal to 27 plus 273 is equal to 300 Kelvin. P2 is unknown, and T2 is equal to 77 plus 273, which is equal to 350 Kelvin. Substituting these values, we get P over 300 is equal to P2 over 350. Therefore, P2 is equal to P times 350 all over 300, which is equal to 1.16 P Newton per meter squared. Example 8. A given mass of gas has a pressure of 80 Newtons per meter squared at a temperature of 47 degrees Celsius. If the temperature is reduced to 27 degrees Celsius with volume remaining constant, calculate the new pressure. General gas law. The general relationship between pressure, volume, and temperature of a given mass of gas is called the equation of state or ideal gas law. By combination of Boyle's and Charles' law, we obtain that PV over T is equal to a constant. P1 V1 over T1 is equal to P2 V2 over T2. Example 9. A quantity of sunglass at minus 133 degrees Celsius occupies 1 over 3 meter cube under a pressure of 1.4 times 10 raised to the power minus 5 Newton per meter cube. If the glass occupied 31 meter cube at 37 degrees Celsius, calculate its pressure. Solution. Using the ideal gas equation, P1 V1 over T1 is equals to P2 V2 over T2. We have that P2 is equals to P1 V1 times T2 all over V2 times T1. But P1 is 1.4 times 10 raised to the power 5 Newton per cubic meter. V1 is equals to 1 over 3 meter cube. T1 is equals to minus 133 plus 273, which is 140 Kelvin. V2 is 31 meter cube. T2 is equals to 37 plus 273, which is equals to 310 Kelvin, and P2 is unknown. Substituting these values, we have P2 equals to 1.4 times 10 raised to the power 3 times 1 over 3 times 310 all over 31 times 140, which will give us 3,333.3 Newton per square meter. Example 10. A mass of gas at 7 degrees Celsius and 70 cm of mercury has a volume of 1,200 cm cube. Determine its volume at 27 degrees Celsius and pressure of 75 cm of mercury. Solution. Apply ideal gas law. P1 V1 over T1 equals to P2 V2 over T2. V2 is equals to P1 V1 times T2 all over P2 times T1. But P1 is equals to 70 cm mercury. V2 is equals to 1,200 cm cube. T1 is equals to 7 plus 273, which is equals to 280 Kelvin. P2 is equals to 75 cm mercury, and T2 is equals to 27 plus 273, which is equals to 300 Kelvin. On substituting these values, we get V2 equals to 70 times 1,200 times 300 all over 75 times 208, which is equals to 1,200 cm cube. Measurement of heat. Heat formula. Heat Q is equals to MC change in T, where M equals to mass of body, C equals to specific heat capacity of the body, and change in T is equals to change in temperature. Heat capacity. The heat capacity C of a body is the quantity of heat required to raise its temperature by 1 degree. Unit is joule per Kelvin. Specific heat capacity. The specific heat capacity C of a substance is the quantity of heat Q required to raise the temperature of a unit mass 1 kg of heat through 1 degree. Unit is joule per kilogram per Kelvin. J kg per K. Note: heat thermal (thermal) capacity C is equals to mass M times specific heat C. C is equals to C is the specific heat capacity is equals to MC. Calculation of specific heat capacity.